In my multi-agent chat application, I created a new agent, and it's called Booking Agent. This app is built with a new framework on the top of LangChain called LangGraph, designed specifically for stateful multi-agent applications. There are many SDKs and frameworks worth exploring, but the most popular and flexible one is LangGraph. While it has the steepest learning curve, it offers extensive customization and powerful capabilities. With the LangGraph library itself, you can build powerful multi-agent workflows directly in the code. But with LangGraph Studio, you can do even more: visually debug, monitor state in real time, and deploy those workflows. As you can see, I have created multiple agents in my projects. The simplest one is a chat agent. You ask questions and receive text responses. The second is a search agent that queries the web in real time, so you can, for example, ask about the weather in Los Angeles and get an immediate answer. The third is a job notification agent, where you can review candidates based on their skills, move to the next matching candidate, and if suitable match is found, automatically send a notification email. These agents are already implemented and available in my GitHub repository. And the last agent I will demonstrate is the booking agent, where you can search trip destination, find hotel for the selected destination, actually download hotels list for the selected destination, select the hotel, and pay using Stripe. And if everything is successful, you just can review your trip summarization. Note we also have a supervisor agent, which acts as an orchestrator or router. When the agent is invoked, it selects the most appropriate agent from the list based on the user's prompt and returns the response to the user. Now we will select the booking agent to demonstrate its functionality. Let's write the following prompt. I want to travel to Egypt. First, you will see some information about that destination, and after that, a carousel UI is rendered with available destinations. You will see later that agent development that interacts with the UI is fundamentally different from standard web development. In our application, we use the Booking.com API from Rapid API to access hotel data and integrate it into our booking flow. As you can see, there are several Booking.com implementations. The Booking.com on Rapid API is made by third-party developers. They provide a way to access Booking.com hotels data. But the actual Booking.com doesn't officially support these APIs, but many people still use them successfully in their applications. Our application uses two APIs. The first one is Search Hotel Destination API. That API handles hotel destination searches and is displayed in our multi-agent chat UI as a carousel control. This is the API response that we use in our carousel control. I actually rendered our carousel control based on this response. We run two projects. The first one is a front-end React application, the UI layer that users interact with. It handles the chat interface, hotel cards, booking forms we will see later, and more. The second project is the backend LangGraph agent app, the AI agent that processes booking logic. It handles trip classification, destination search, hotel search, payments, and more. The backend application contains the core business logic and AI workflows. Now, LangGraph lets you deliver React components from the server to the client, connecting the UI directly with the AI workflows. Generative user interfaces, it's called generative UI, allows agents to go beyond text and generate rich user interfaces. So the carousel React components are pushed from the server to the client. That can be viewed in our Graph Studio as well. Under the most recent thread, here is the thread number. We can see the components and the state. Here if we go display trip destinations, UI, props, destination, data, and here you can see all destinations information. On my GitHub page, the documentation provides a detailed explanation on how our React components can be streamed with LangGraph behind the scenes via entry-point.js. When we call Search Hotel Destination API, the result includes both the destination ID and destination type. The destination type can vary even though we call with the query parameter Egypt. It could be country, city, hotel, the landmark, and so on. The second query we need to call is searching hotels by selected destination, where we include several parameters, such as the destination ID. We already obtained the search type, which is the destination type, arrival date, departure date, number of adults, number of children, room count, and etc. When I click a destination on the carousel control, a side panel opens allowing us to search for hotels by entering the necessary information for that destination. And you will notice that React components sent from the backend server can be rendered not only inside the chat window but also elsewhere, such as in the right-hand side panel. This is made possible using React hooks and React portals, a feature that allows components to render outside their parent's usual DOM hierarchy while maintaining their state and connection to the React component tree. Before searching hotels, we perform some validations. And the dialog indicates that past dates are not allowed in this case. And the warning says arrival date must be before departure date. Let's select check-in date of September 15th and the checkout date of September 24th with 2 adults, 2 children, and 1 room. After clicking, we first receive hotels information and hotels cards components are pushed from the server to the client. When I click on a hotel, we see the hotel information and its location on the map. Now let's select Guan Resort in New Alamein. But first I'll select hotel without accepting terms and conditions. And I'll do it intentionally. I intentionally skip the client-side validation to demonstrate that we can store information not only in state messages, but also in the configuration. And it's often better not to expose this data in state messages because storing it in the configuration allows it to persist across different parts of the map and be reused by other agents that you can see in the source code. And you see that terms and conditions are not accepted. So this time I will accept it. Now we can process it. We can process the trip using Stripe. But I want to tell you that this is not real booking.com, and in many cases you may not be allowed to process it. However, I would like you to show you in the Stripe test mode how we can safely handle the payment. And here is the Stripe secure payment processing. And what I want to show is that at this moment you can still select another hotel or destination, search for hotels and pay with Stripe. So I can go select hotel, search for hotels, and pay. But however, once payment is completed, these options will be disabled, and this is by design. We will explore some cases later on. Let's make payment. I should enter my email address, card number for testing, it's 4 and 2, some arbitrary amount and year and CVC. After completing the payment, a summary report of my trip was displayed. Now if I go back, I can see that the Pay with Card button is disabled and other action buttons are also disabled. Even after refreshing the page or switching between threads, the buttons stay disabled. And in this case, no API calls are made. All data is served directly from Graph Studio. Now we will go to the Stripe transaction page to check the hotel payment details. Before testing some scenarios of the booking agent, I would like to talk about AI agent development. AI agent development versus web development. Creating an LLM large language model agent is generally harder than building typical web application because it involves multiple layers of complexity that go beyond standard web development. Uncertainty and unpredictability. Web applications are deterministic. The same input always produces the same output. LLM agents are probabilistic. Their responses depend on training data and the context of the query. The same prompt can give different results each time. You must handle edge cases, hallucinations, and inconsistencies, which do not occur in normal web apps. Complex state management. Web applications often manage structured data, such as user profiles, shopping carts. LLM agents need to manage conversation history, tool usage, interruptions or classifications, context retention across multiple terms. This is much more dynamic than typical state in web applications. Integration with external tools and APIs. LLM agents, often called APIs, databases, or other services on the fly, like in our booking agent, based on user intent. You must ensure correct sequencing of tool calls, error handling, if a tool fails, security when exposing tools to an LLM. In web applications, API calls are usually predefined and simpler. Prompt engineering and reasoning. You need to design prompts so the LLM behaves as desired. Small wording changes can drastically affect the output. Web applications rely on explicit logic and you fully control. You do not need to teach them how to think. So a web application is about control, structure, and predictability, while an LLM agent is about uncertainty, dynamic reasoning, and context-sensitive behavior. This is why building an agent is generally more challenging. With LLM agents, failure cases are inevitable, unlike traditional web applications, which can usually handle every possible input. LLMs deal with open-ended human language, so there is always a chance of failure. The goal is not to eliminate failures completely, which is impossible, but to minimize and handle them gracefully. There are rules for developing LLM agents, and the first one is a modular design. Break a complex agent into smaller specialized sub-agents or tools. Each sub-agent handles one well-defined task instead of trying to do everything. In our booking agent, the first one is a search trip destination, which connects to the search hotel's destination API based on the user prompt and adds the trip destination to the state. Display trip destination uses the retrieved information to generate destination details, including interesting facts and highlights, and also pushes the trip destination UI component to the client. Search hotels by destination connects to the search hotels API using the destination information and adds the hotel details to the state. Display hotels destination generates the brief summary of available hotels and their key features and pushes the hotel UI components to the client. Select hotel checks whether the terms and conditions have been accepted. If not, send a message to the client. Otherwise, prompt the client to proceed with Stripe payment. Process Stripe displays the Stripe payment button and payment information. Proceed with payment if the user agrees. Otherwise, ask the user to go back and select the hotel. Pay Stripe processes the payment, which can be verified on the Stripe transaction page. Summarize Trip displays a summary of the trip. Benefits are easier to debug, test, and improve individual models. There is also another rule, pass only relevant state. Instead of giving the agent the entire state, we only provide relevant slices. We apply this rule in many places in our agent, but I would like to highlight the summarization agent. Here, we pass only the relevant state of the selected trip for summarization. For instance, you might ask to go to Egypt, pay for the trip, and see the summarization. Later in the same chat, you could plan a holiday in Italy, select the destination, choose a hotel, and pay. When retrieving the summarization for Italy, we should not pass the entire state to the LLM. Instead, we only pass the part related to Italy, not Egypt. This ensures that LLM focuses on the relevant context and reduces errors. Consider costs. When developing an API-based agent, you should consider costs for API calls, LLM usage, and other services. Most APIs are not free, and multiple API interactions can increase costs unexpectedly. For example, using the Booking.com API incurs additional costs, as you can see. In this application, I also pay for the GPT-4 mini model, which costs 20-40 times less than GPT-4. However, GPT-4 should be used for tasks that require complex reasoning. Before the artificial intelligence era, when we developed an app, we mostly typed the code ourselves or copied some snippets from Stack Overflow. With AI, there are now editors like Cursor that can write code for you based on your prompts. Many studies have examined whether AI-assisted coding actually speeds up development. One study found that developers using AI tools took 19% longer than those who didn't, suggesting that in some cases AI can actually slow development down. When using AI for coding, it sometimes fails on a very simple line of code, but once you point out the problem, it can fix it. Sometimes you ask it to generate code for something, and when you inquire whether another approach might be better, the response often starts with "you are absolutely right" and follows the suggested approach. Despite these cases, AI-assisted coding is very helpful. I am not sure about large projects, but for medium-sized ones, it works quite well. For the Booking.com agent with an AI in the same project, I typed maybe 5% of the code and the remaining 95 was generated by Cursor. A task that might take a few weeks without AI can accomplish in a day if you write proper prompts. Since English is the main language for prompts, the more precise you are, the fewer prompts you will need for the same task. The server-side React components, which are pushed from the server to the client, along with the Booking.com API calls, were almost entirely written by Cursor. For that reason, I scaffolded with project using AI in just a few minutes, instructing it to generate starting page based on the HTML static page. Then, through prompting, I generated all the UIs and tested them in real time using the Booking.com API. Then I copied it all into the Booking Agent project. LangGraph renders its UI components inside the shadow DOM, which keeps their styles isolated and prevents conflicts with the rest of the application. For that reason, I ask AI to generate styles that include bootstrap references and some custom CSS. If you use Tailwind or class name, C and libraries, you don't even need to do this. These components work out of the box. That's how I generated the UI component part. Some people think an AI editor is used simply to generate code. However, you can collaborate with the AI on a project. You can discuss the code, ask for better solutions, and more. Of course, you need to know what you are doing. When I started developing the agent, I realized that during development, it could handle only one trip reservation at a time in the same conversation. If you try to cancel it in the middle or request a second trip, it fails. What I first do is copy and paste an API response, and based on that response, the AI generates other interfaces. When I when I noticed the problem, I asked the AI about it, and it started fixing the issue throughout the code, beginning with the types TS. Now I can handle multiple trips within the same chat. And when I started testing the application, I encountered another problem. At any point, I might want to change my trip, for example, after displaying the hotel components or before making payment. For instance, if I say I want to travel to Egypt, the app shows the destinations. At that point, if I write, can I change the trip to Spain instead, the agent fails because the graph logic cannot handle it. I explained the problem to the AI and it generated a new agent called classified trip requests, added some logic and updated the graph. Though the code wasn't final and the prompt was weak in other cases, I could achieve all of this just by explaining to AI what to do, rather than writing code myself. Now when you prompt something, you can see in the graph that it goes through classified trip requests. If the AI detects that the user has changed their trip destination, it can handle it correctly. While writing the booking agent, I consulted the AI in many cases. This raises the question, who should use AI? Experienced developers who come from the AI era and have coded for many years, or junior developers? I think experienced developers should definitely use AI, as they can review the code and identify issues or optimizations. Although it may take some time to figure out and fix problems, overall they will save a lot of time compared to doing everything manually. Juniors should not delegate all tasks to AI, as they may not be able to identify issues. Probably the best way to learn coding is mostly the traditional way, while using AI to some extent as a support. This is just for today. We don't know what will happen in a year or two. Let's start testing. I selected the booking agent. Let's type book me a trip to Japan. We retrieve the destinations. Actually, we can search for hotels. We can select the hotel. To pay this process. So now, instead of paying it, we can now change the destination. We can write, can we change the trip to Spain instead? Can we change the trip to Spain instead? You can see that the pay button and other action buttons are disabled for the previous trips. They are disabled in two cases, when we either complete the payment or cancel the trip. Let's start a new chat. Let's type, I want to go to Greece. Even when we refresh the page, all data is preserved and no API call is made. They are loaded from the state. Now I go to the previous thread and continue with Spain. We can search for hotels. Select a hotel. Yes, please do it. We will pay this time. Here is the summary and all buttons are disabled. Let's view transaction history. The payment should be visible on the Stripe page. Let's start a new chat. I am planning to spend my holiday in Italy. I can actually even edit my prompt. For example, I can type, I would like to go to Dubai. As you can see, I created two branches like in ChatGPT, and in Studio they are shown as forks. So it said I would like to go to Dubai and I am planning to spend my holiday in Italy. So I can continue chatting or typing on any selected branch. For example, on the first branch, I just can search for hotels. And actually, they are all kept in the state, so we can refresh and test it. So if I refresh it, I still can see the branches. This is the first branch. This is the second branch. Now let's try the supervisor agent. Let's change supervisor agent. For example, let's type, how are you? Or what's the weather in Yerevan? As you can see, I didn't format the response, so it's in a JSON format. The search agent is used to fetch real-time data. As you can see, in the chat case, the router redirected to the chat agent, and then in the second case, it's redirected to search agent. Let's start a new chat and tap, and I'm tapping. I want to plan a trip to Thailand. You can see that booking also works through the supervisor agent. I can type, I'm thinking about visiting Canada this summer. You can see that this time the booking agent is called.